Happy December 18th. There's only 1 week left. Well, today I want to talk about what I think is one of the best measurements that we've ever seen in any experiment in physics, and that is the measurement of the Z width. Now, the Z boson was produced at LEP. It was also produced at SLAC, in the SLAC Large Collider. And both of these accelerators produced these Z bosons, and we saw them decay in the different detectors. And one of the things that you can do at an electron-positron collider is measure the centre of mass energy. And using that, you can actually measure the natural width of a particle. And when you have a natural width of a particle, that tells you things about the lifetime of the particle and about how many final states it can decay to. So, the 4 experiments at LEP, that's Delphi, Aleph, L3 and Opal, all measured these properties of the Z boson. And when they measured the width, they also measured the number of neutrinos, because the Z can decay to neutrinos. And what they did was combine the measurements across all 4 experiments, and they found out the number of neutrinos was 3. Now, they had predictions of what the width would be if they had 2 or 4 generations of neutrinos, but it came out spot on 3 generations. And that tells us that there are probably only 3 generations of matter. Now, I've already discussed previously that when you have 3 generations of quarks, you get CP violation, you get matter-antimatter asymmetry, and then you get a solid object like this table, and the universe is the way we expect it to be based on what we see around us. But that doesn't stop us having 4 generations of matter, or 5, or 6, or any other number. So what we needed to do was to appeal to some experiment to say, what can you tell us about the number of generations of matter? What limits can you place? And effectively what they did was say that if there is a 4th generation of matter, the neutrinos must have a mass greater than 45 gigaelectron volts. And that is many, many orders of magnitude heavier than what we see with the neutrino masses that we've measured since then. So, for example, a neutrino mass is around a millielectron volt. That is 12 orders of magnitude smaller than 45 gigaelectron volts. So, basically, if there's a 4th generation of matter, it's very, very weird. Now, since then at the LHC, we've also made measurements concerning Higgs production and whether or not that tells us that there's a 4th generation of matter. And basically, we don't see a 4th generation there either. So we've got very stringent limits coming from the neutrino sector and from the quark sector to tell us that there is no 4th generation of matter. And that in itself is pretty cool. So, okay, I'll see you tomorrow for the next video. For as long as I can remember, from as young as I can remember, my parents have always given me 2 things every Christmas. In addition to the other things they gave me, there would be a very long stocking full of all kinds of toys, and this was designed to keep us entertained for as long as possible. We had a family with 4 children, so that's a lot of presents to wrap. My parents would stay up all evening and all night wrapping these. They'd get to bed very late, and they would actually leave these very, very long Christmas stockings. It was actually inside a football sock. And we'd spend, 2 or 3 hours in the morning opening these things, playing with them, and then when we got old enough to realise that our parents needed sleep and that there was no Father Christmas, we'd spend a bit longer playing with these so that our parents could get some more sleep. But at the very end of the stocking, there were always 2 things. There was always a Granny Smith apple and 1 or 2 Satsumas. And so whenever I see Granny Smith apple and the Satsuma, it always makes me think of Christmas and my family when I was a child. So for me, this is about as Christmassy as I can get. When I got older, we'd also have Terry's chocolate orange, but I couldn't find a Terry's chocolate orange here in France. I'm looking forward to getting one of those when I get back.